Alrighty, so let's talk about something called complex fractions. And a complex fraction is a fraction that contains a fraction. So whenever you see fractions that are stacked, those are complex fractions, like these two examples that I have here. So whenever you're dealing with these, the first thing you want to make sure that you understand is where the major division sign is. So in this first problem, it's right here. I sometimes draw little dots on the end to make sure I know where it is. And in the yellow problem, it's here. Now, I'm going to work through these two examples so you can see how they look. The first example is very similar to one that we did in the last section. It's just a division problem where everything is written stacked. So what we're going to do is to start by writing this same switch flip. So the top fraction, or actually, you know what I think I'll do? I think I'll start by rewriting it as the division problem it is. So it looks more like what we did before. Then I can do the same switch flip. So same. Switch the division to a multiplication, flip the second fraction. Alright, so now I've got this as a multiplication problem. And remember, we always want to try to simplify the fractions before we multiply them. So we're going to do that by factoring. So the 4x squared minus 1 is the difference of two squares. So that's going to be 2x plus 1 and 2x minus 1. And then that bottom thing has a common factor in it I'm going to pull out first. And that's 3x. That would leave me with an x squared minus 2x minus 8. And then x squared minus 2x minus 8 factors. So this is going to be 3x times x minus 4 times x plus 2. Likewise, if I look at the top of that second fraction, no common factor there, so I'd actually have to use a box. This is 2x squared, this is negative 2. I want two numbers that multiply to give me negative 4 and add to give me negative 5. I wrote the problem wrong. This is supposed to be a plus. So we'll fix that all the way up and down. So two numbers that multiply to give me positive 4 and add to give me negative 5. This would be negative 4, negative 1. So I pull out the common factor in the first row, which is 2x, and then I go around and make the box work. So it's going to be 2x minus 1 and x plus 2. And then on the bottom, we got another common factor we can pull out. Pull out a 3. That would be 4x squared plus 4x minus 3. And then that also factors, and you would use the box again. So let's see. 4x squared, negative 3. Two numbers that multiply to give me negative 12, that add to give me 4x, are 6x and negative 2x. So I pull out the common factor. That would be 2x here. And then that makes this 2x, which makes this negative 1, which makes this positive 3. So I have the 3 that I pulled out times those two factors. I'd get my excluded values, which here would be 0, 4, by the way, 0 because x can't equal 0, negative 2, 1/2, and negative 3/2. And now I'm going to go about simplifying. So simplify fractions first. The individual fractions don't look like, though the second fraction, I can cancel those things out. And if I look at cross-canceling, I've got an x plus 2, and that looks like it's about it. So then at the end, I would multiply all that stuff out. So 2x plus 1 and 2x minus 1 give me 4x squared minus 1. And then on the bottom, x plus 4 times 2x plus 3, well, 3 times 3x gives me 9x. And then 2x plus 3 times x minus 4 is 2x squared minus 5x minus 12. And then I would multiply that out. And then write all the excluded values next to it. So essentially with that one, you rewrite it as a division problem, and this one was pretty complicated in the factoring. The idea is the same, just treat it like a normal division problem. The second example over here, however, is a little bit different. So when I look at the second example, you see how I've got addition of two fractions on the top. Before I do the same switch flip, I need to take care of any addition or subtraction that's being done on top or bottom. So I need to combine fractions first because they're grouped together by this fraction bar. Since it's a grouping symbol, it's at the P level of PEMDAS. It needs to happen first. So I'm going to add those fractions together first. So I need a common denominator. A minus 1 can't be factored. A minus 4 can't be factored. So the common denominator there is going to be a minus 1 times a minus 4. I would have to multiply this first fraction by a minus 4. So I have to do it to the top as well. And 2 times a minus 4 is 2a minus 8. The second fraction, I have to multiply by a minus 1. So I have to do it to the top. So that would be 3a minus 3. And then when I add the fractions, I add the numerators, so it would be 2a minus 8 plus 3a minus 3. And then those denominators stay the same. But in this case, I'm going to go ahead and leave them factored. I don't want to combine everything until I get to the end, because things might simplify. And they simplify when they cancel, right? And we cancel when we got them factored. So now this problem looks like the one we did at first. We're going to rewrite it as a division problem. Then we're going to same switch flip. Then we're going to factor to simplify. 5a minus 11 doesn't factor anymore. We've already factored the a minus 1 times a minus 4. 6 is there. And then we have a squared minus 5a plus 4, which factors into a minus 1 times a minus 4. We write our excluded values. A can't equal 1 or 4. Then we cancel. And then our answer would be 5a minus 11 over 6, where a doesn't equal 1 or 4. So when you have complex fractions like this, think about where the major fraction bar is, take care of any addition or subtraction that's being done on top or bottom, and then rewrite that as a division problem and go from there.